Good afternoon, everyone. I believe this is the last session for the afternoon, so thank you for bearing with me for the next 20 minutes. I'm always a beer lover, so if you guys are interested in topic, we can always talk in the reception. All right, so let me introduce myself first. My name is Lou. I'm a software architect in wireline perforating at Halliburton. So I know folks are talking about hardware and tools and sensors, so let's shift the subject a little bit on the software side. Okay, so our software group is mostly design and implement the software solution for both real-time data acquisition system and the post-processing answer products. Today we would like to share some of our learning experience with recent couple of years, the challenge we're facing, and the system come with design and implementation, mostly for the large data set, data management, and the processing. All right, so with the fast development, new technology everyone talked about today, and the innovation of the new sensors and new hardware, also, and the development also in very, very fast cycle. With the new sensors, it allows us to acquire data in much faster speed and allows us to acquire data in much finer resolution, both of results in very large data volume, right? And also the new sensor allow us to acquire new data types, introduce new machine learning, deep learning algorithms so that our data scientists have capability to explore and analyze the new attributes and the new features to extract. All those new development and stuff give software a challenge, how we keep our software up to speed so that we can effectively and efficiently manage the data and process the data efficiently. As we mentioned, the first challenge is data. So once the raw data is being acquired in the field, the subsequential of the data volume increase dramatically, including metadata, recording every single history transaction of auxiliary data associated with the raw data, the intermediate data between the steps, the final delivery data, process data, and the user reports. All of those different category data will require both accessible by human beings, including SMEs, and users, data scientists, and also machines. Right? And nowadays, everyone will say, as user, I would like to access my data from anywhere, anywhere, right? So without a systematic solution, I think it's just mission impossible. Another challenge we have for software team is processing and validation. Many of our legacy software, when we designed, it was not designed for the large data set, right? I don't know how many software developers we have in the room, but myself, as a software developer, every time I'm facing the fight, should I just refactoring the existing software or just start from new? I create a brand new software with modern architecture, right? The situation will be case by case, right? But most of our legacy software, it just doesn't work. Or even it works, we're facing extremely long processing time, or facing extremely long SMA validation time, involve more iterations, and introduce higher risk for the user errors. So all of this end up with frustration and failure, right? As a software team, so what do we should do? In many cases, we do have to break our existing system badly, reorganize all the pieces with modern architecture, make the software back to work and work better. And many people will through an answer, well, just put everything on the cloud. The cloud can resolve everything for us. Simple and sweet. Okay, so is that the answer? Well, I would say the answer will be yes and no, right? So if you review all the major cloud vendors solutions, they pretty much provide very similar services. They provide a data solution, data lake solutions, computation power, machine learning, deep learning services. I don't know how you guys joined this morning's workshop. I totally agree with some speakers today mentioned that the key point is not the cloud solution. The key point is you have to understand your data model, you have to understand your working flow, and you have to understand the dependencies, right? So with those key points, you can design and have your correct deploy strategy. That's the key point. So you have to understand your business requirement, understand your technology requirement. So let's say your company do have the digital strategy as vendor-driven. Then the short answer could be yes, right? So you can focus on the specific services the specific vendor provide. Then you probably will come with relatively fast implementation and easier deployment. However, the drawback is also very obvious. When you design the software, pretty much your architecture and your implementation will be coupled and depend on the specific vendor. So similar-wise for your cost model. And per our experience, in many cases, some region, the cloud solution is limited due to different reasons. Could be a data sensitivity, could be hardware issue, could be support issue. So driven by this business requirement, with our software team basically come up with a flexible but also generic solution architecture that utilize microservices architecture plus the most well-known and stable industry standard components and libraries. Here we just list a collection of examples, not necessarily limited to those examples, right? For example, we're using the Spark. The main reason we utilize the Spark is, first of all, it's open source and well supported in multiple programming language. It originally in Scala, but also have good support for Python, Java, C#, right? And also support cross-platform. And in our POC, we do implement and design a generic Spark microservices utilize the Spark. And another example here we're using for the streaming capability, we use a RabbitMQ, which implements based on the AMQP, which is Advanced Message Queue Protocol, which support either point-to-point or pub-sub pattern. And now it's also very easy to use, and we can have the very easy capability to have the streaming input, output, and immediate user feedbacks. So the key tech point for our solution is both our services can be deployed either on-premise or in the cloud, and even in the cloud, we call it support cloud provider agnostic solution, so which means it's transparent to the client application, really doesn't care which vendor it is. So as a POC, start with a project. As a POC, we pick example use cases that the computation is extremely heavy. It does require machine learning pipeline cycles, including the model building and turning. However, the data volume is relatively small, so we're talking about gigabytes level, so it's not that huge at all. So given this challenge, based on we just reviewed the solution, we design and implement our generic Spark Engine microservice with Spark cluster, and also we deploy the RabbitMQ services to be able to communicate streaming the data stream and also the user feedbacks. And we also design our own machine learning microservices, utilize the TensorFlow and scikit-learn behind the thing. So as a POC, initially we deployed on-premise. We do have our internal cluster, which is roughly like a 128 core, so it's not that much. However, you already see the performance improvements and also have the proof of concept that you can scale out horizontally, right? So the next step we do is we deploy the same solution without any extra effort into Azure, which in this case we do have like thousands of cores. Which we also improve that our performance improves to another level. Another use case we have is seismic processing. So compared to the previous work on the seismic processing project, we're facing mostly on the data volume. So compared to the previous one, the data volume for this use case is much larger. So we're talking about hundreds of terabytes. And also, the data needs to be processed in multiple iterations. Given on the problem we have, the first solution we come up with is we co-deployed the computation cluster and the data cluster together on-premise. The reason for that is we try to minimize the latency between the data and the computation. We try to avoid the data transfer between the data nodes to the computation nodes. However, yeah, it works pretty good on-premise in our internal cluster. However, when we try to deploy the solution into the Azure, we're facing a couple issues. First is horizontal scalability, right? So currently, with this solution, the computation is coupled with data. So when you try to scale out horizontally, we do facing cost-wise, it's pretty expensive. And also, we do require extra storage count to archive all the processed data. So based on this limitation, we come up with a second solution. Naturally, we separate the computation and the data into separate clusters, which give us the capability to horizontally scale computation and the data separately, and give us pretty benefit on the cost and the maintenance. However, on the other hand, the limitation will be data transferring latency between the cluster, between the computation and the data clusters. So do give us a requirement for our cloud vendor. Either these two clusters need to co-located in the same region, the same data center, or it has to provide good enough network bandwidth to fit our purpose. So combine the first and the second solution, we come our third option. We introduce a cache cluster in between the computation and the data cluster. The caching cluster also being recommended by co-deployed onto the computation. Remember the challenge we have at the beginning, the data need to be processed in multiple iterations, which means it's kind of, you can consider whatever data in process is hot data, so it's being over processed in multiple iterations. So instead of transfer all the process data all the way back to the data cluster and kind of plumbing back and forth, we utilize this cluster, the caching cluster to kind of caching all the hot data so that it can facilitate the computation cluster. The reason we have to introduce the caching cluster is in our use cases, we do require the random access, which means if the data being processed in this iteration, in this fashion, it's not necessarily the same sequence in the next iteration. That's why we cannot holding the data onto the same Spark cluster, because it's not guaranteed it will be accessed by same sequence by the same node, basically. So to summarize, the key takeaway for our talk is no matter. So basically, what the system will come up is flexible enough, and so that you can plug in any generic services you need. And however, it's specific in a way that you have to understand your data model, your working flow, and your business requirement. Because you have to generate in extent. You cannot generically do everything. Basically, that's too open-ended, right? Another key point is the system has to be, all the library or component and the microservice deploy have to be deployed both on-premise and on cloud. And that's it. Right on.